All right, so we're going to begin chapter 4.4, which is simplifying complex fractions. And I wanted to go ahead and give you a definition of complex fraction. A complex fraction is a fraction where the numerator denominator or both contain a fraction. So complex fractions may look like, say, 7 over 1 minus x over 3 plus 2 over x squared. Or you might have something like 1 over x plus 3 minus 2 over x over 17 over x plus 7 over x squared. Both of these are examples of complex fractions, and our job is to try to simplify complex fractions. To simplify, we're using a method called clearing the fractions. Clearing the fractions. And this just simply involves finding the LCD and multiply each term by the LCD. So I'm going to work a series of examples from the homework so you guys can see exactly how this works, okay? Example. If I have to simplify 3 minus 4 over x divided by 5 minus 7 over x, first establish that the LCD is equal to x. That's the only denominator on the fractions in the numerator and denominator. So I'm going to multiply every term by the LCD, x. So 3 times x minus 4 over x times x divided by 5 times x minus 7 over x times x. And that allows me to go ahead and cancel out these x's right here. And that leaves me with my answer, 3x minus 4 over 5x minus 7. This answer that we get in the fraction for the answer is no longer complex fractions because there's no longer fractions in the numerator or the denominator. Another example. 1 over x plus 9 over 5 over 1 over x plus 7 over 8. In this case, we see that the LCD is a product of x, 5, and 8. Which is equal to 40x. So to solve this, we would multiply everything by 40x. So 1 over x times 40x plus 9 over 5 times 40x over 1 over x times 40x plus 7 over 8 times 40x. And now we look at what can cancel out. This can cancel out, x and x. And 5 into 40 is 8. X cancels out with x here, and 8 into 40 is 5. This leaves me with 40. 9 eighths are 72. There's an x here, divided by 40 plus 7 times 5 is 35x. Do not try to cancel out the 40 here because 40 has a plus sign attached to it, and we're not allowed to cancel out if there's a plus sign attached to it. Example. Three over 4 over x plus 2. Again, the only LCD here is just one fraction, fractional denominator x. So everything gets multiplied by x. So this is equal to 3 times x over 4 over x times x plus 2 times x, which is equal to 3x. This cancels out here. 4 plus 2x. More examples. What? 9 over 7 minus x over 5 over 4 plus x. Looking at 7, 4, and x, we can see that the LCD must be comprised of only 7 over 4 because this is x over 1 and x over 1. So the LCD is equal to 28. So this is 9 over 7 times 28 minus x times 28 over 5 over 4 times 28 plus x times 28. 7 into 28 is 4. 4 into 28 is 7. So on the numerator we have 9 fours or 36 minus 28x. And on the denominator we have 5 sevens 35 plus 28x. Example. 1 1 over x plus 7 over 1 plus 1 over x plus 7. So the only denominator on the fractions in the numerator and denominator here is x plus 7. So the LCD is x plus 7. Everything gets multiplied by x plus 7. So 1 over x plus 7 times x plus 7. 1 times x plus 7 plus 1 over x plus 7 times x plus 7. Now we can see that we'll cancel x plus 7 and x plus 7, x plus 7 and x plus 7. And this leaves us with 1 on the numerator. Distribute the 1 into x plus 7. We have x plus 7 plus 1, which is 1 over x plus 8. Example, 1 plus 7 over x divided by 1 minus 49 over x squared. So the LCD has to accommodate both x and x squared. Since x goes into x squared, the LCD is x squared. So everything gets multiplied by x squared. 1 plus times x squared plus 7 over x times x squared. And if you want, you can write x squared as x times x, just so we can cancel out that x there. 1 times x squared plus 49 over x squared times x squared. So this is x cancels out with one of the x's here, and x squared cancels out with x squared. Now fractions are wrong. That leaves me with x squared plus 7x I think I messed the sign up here. This should be negative. Yes, it is. So this is x squared minus 49. At this point, when we think that this problem is done, we see common factors that can probably cancel out. So let's see if we can do anything here. We can take out an x on the numerator, factor out an x, that leaves x into x plus 7. And on the denominator, notice that we have difference of squares right there. So that is x plus 7, x minus 7. And that allows me to go ahead and cancel out the x plus 7. That leaves me with x over x minus 7. Example, 2x plus 4 over 2 over x squared plus 1 over x. So notice that the denominators on these fractions are x squared and x. So the LCD x squared will accommodate both x and x. So we multiply everything by x squared and see where that gets us. Okay. So here we go. we can do 2x times x squared plus 4 times x squared over 2 over x squared times x squared plus 1 over x times x squared. X squared cancels out here. X cancels out with one of the x here. That leaves me with 2x cubed plus 4x squared over 2 plus x. Now notice that on the numerator we can factor out both 2 and x squared. That leaves me with, right here we can factor out both 2 and x squared from there. That leaves me with 2x squared on the outside. I leave a single x here, and then 2 goes into 4 2 times. On the denominator, 2 plus x is the same as writing x plus 2. And it cancels out with x plus 2 cancels out to give 2x squared. Simple. 1 plus 4 over x minus 4. 1 minus 4 over x minus 4. So our LCD is equal to x minus 4. That means everything gets multiplied by x minus 4. So this is equal to 1 times x minus 4 plus 4 over x minus 4 times x minus 4 1 times x minus 4 minus 4 over x minus 4 times x minus 4. Distributing 1 into x minus 4 in the numerator, we have x minus 4 plus 4. And on the denominator, we have x minus 4 when we distribute 1, x minus 4, and then we have a minus 4. So right here we can see that plus 4 and minus 4 cancels out, and it leaves us with x over x minus 8. Example 6 over x minus 1 minus 2 over x plus 1 x over x minus 1 plus 1 over x plus 1. Observe that the denominators have to accommodate x plus 1 and x minus 1, so we can establish that our LCD is the product of x minus 1, x plus 1. Multiply everything by that LCD, so here we go. 6 over x minus 1, x plus 1, x minus 1, minus 2, over x plus 1, x over x minus 1, x plus 1, x minus 1, plus 1 over x plus 1, x plus 1, x minus 1. And we look for opportunities to cancel here. X minus 1 cancels with x minus 1. X plus 1 cancels with x plus 1. X minus 1 cancels with x minus 1. X plus 1 cancels with x plus 1. So at this point, we're going to be really careful. So I'm going to write back what we have left here. This is 6 into x plus 1 minus 2 into x minus 1 over x into x plus 1 plus 1 into x minus 1. Now we want to go ahead and see how best we can simplify this. So distributing on the numerator, we have 6x plus 6. Then we have negative 2, and the numerator again, right here. Be careful with this, because this is negative 2 times x is negative 2x, and then negative 2 times negative 1 is positive 2. On the denominator, x into x plus 1 gives x squared plus x. And then distributing 1 into x minus 1, we have plus x minus 1. So collecting like terms here, we have 6x minus 2x is 4x, and 6 plus 2 is 8. On the denominator, collecting like terms, we have x squared plus 2x minus 1. I looked at this carefully, and we cannot, factoring out 4 on the numerator would not allow me to cancel out 4 on the denominator with anything, since the denominator, we're not able to factor the denominator. So this problem is more or less solved as it is right here. Okay? There's nothing else we can do to simplify it further. If we were able to factor the denominator and cancel it with something in the numerator, then that would be a little different. This is all I have for you guys for this chapter 4.4. We'll